And for the very first problem, remember that your final answer should be written as 2 ordered pairs. But if you have a system where one of them is a quadratic and one of them is linear, you want to go ahead and take the 2 expressions and just set them equal to each other since they're both equal to y. So we would start with the x squared plus 5x plus 2 equals 3x plus 5. And then anytime you guys have a quadratic, always make sure you move everything to one side so that we can set it equal to 0 and factor. Okay, so subtract 3x, subtract 5. And if you guys have questions while I'm doing these, please stop me and ask. What would this be? Minus 3 equals 0. Okay, so once you get that quadratic, factor it however you're comfortable. So I have negative, we're multiplying to make negative 3, adding to make positive 2. What are the 2 factors? I have, 3 and negative 1. So x plus 3 times x minus 1 equals 0. So what are your 2 x values? Negative 3 and positive 1. And at that point, that's where most people tend to stop. You just have to remember that we are looking for points of intersection here. So your plug and chug is always easiest on that bottom one, the linear. So the 3x plus 5 is always going to be the easiest place to plug x into. So I can just do that mentally. If I take 3 times negative 3, that's negative 9. Plus 5, my first y value is negative 4. And then if you do the same kind of plug and chug but with the number 1, 3 times 1 is 3 plus 5 is 8. So then I know there's not a ton of room, but you would then want to write 2 ordered pairs. So negative 3 comma negative 4 and 1 comma 8. Is everybody okay? Yep.
I just want to let you know that I cut the test apart.
Okay.
And did a fashion copy and paste and left a bunch of space. So they have workspace.
Oh, okay. Good. Okay, so then is everyone okay with 1?
Yep.
Okay. All right. Then for problem 2, this is a composite function. So when you guys have composite, remember you want to take the one that's close, like the one on the inside, so G. G is the one that we're going to plug into function f, wherever you see the letter x. So instead of writing negative 3x plus 4, I'm going to write negative 3 and then in parentheses put the whole function g in there. So the 2x squared minus 1 plus 4. Now some people, I don't know about you guys, some people may have already plugged the 2 in because eventually they are going to have me do a plug and chug with the number 2. You could have plugged that in for x in that first function and then plugged that number in, but the way I taught you guys was what I'm doing right now. So I'll do the evaluating at the end. We want to distribute negative 6x squared plus 3 plus 4. So you could go ahead and combine these two and make it 7, or you could just go ahead and do your evaluating part now. They want you to now plug in the number 2 wherever you see the letter x. So I would take negative 6 times 2 squared plus 7. So that's just the 3 and the 4 combined. Is everyone okay?
Yes.
Okay, and then, so if you type that into a calculator, 2 squared is 4, times negative 6 is negative 24, and negative 24 plus 7 is a final answer of negative 17. Which on your final, this one may have actually been multiple choice, But whether it's multiple choice or not, you'd still have to work through that process. Yes?
Is that the F of X or is greater than?
Hang on, I didn't hear you. What'd you say?
Is that the F of X? Or is it just negative 17?
We have to write.
You can write F with the, I don't even know how to say that, the composition of F of G, or F with G, of 2 equals negative 17. But I don't usually have my students write all this. I usually just have them circle their final answer.
Thank you.
You're welcome. All right. Number 3, is that relation a function, yes or no?
No.
Because?
It doesn't pass the line test.
Perfect. So that's a no, because it does not pass vertical line test. Is everybody okay?
Yeah.
Okay. Yeah, in order for me to scroll down, this is all going to disappear. That's why I'm asking before I move on. For problem 4, this is all just combining like terms. So anytime I see subtraction, you guys are always going to see me do keep, change, change. So I'm going to change this to plus. My 8 becomes positive, and so does the 3i. And then you guys just combine like terms. So 4 plus 8, 12. And negative 5i plus 3i. Hang on just a second, you guys. There's the final answer. Were you here to take your final, or what do you? Oh,
Yeah, I need to start it.
the geometry one. Okay.
Are you going to be here early in the morning?
Yep.
Okay.
I'm always.
I'm going to be here for Nick at like 7 in the morning, 7:30 in the morning.
I'm always here by like 7:45.
Because I have to be at my job at 9 o'clock in the morning.
Yep, sounds good. So you just sit, work on it. I just can't answer questions because I'm teaching right now. Okay. All right. So does everybody go with 4?
Yes, ma'am.
Okay, perfect. Then for number 5, let me scroll down just a little bit so we can also see range. Oh my goodness. Okay, so problem number 5, it does say to graph the quadratic. So when you guys graph this, the first thing you need to ask yourself is it in standard or vertex form? They are going to test you on standard because it's the harder one, right? Vertex form, you already know the vertex. But this one, we actually have to find our vertex. And in order to find the vertex, you have to find axis of symmetry first. So I know it's listed second, but you have to find that first. Remember the little formula, x equals negative b over 2a? That's what you're doing there. That is on your reference sheet if you forget that little formula. And then what's the opposite of b? 4 times, and then sorry, divided by 2 times a, which was negative 1. So if you do 2 times negative 1, that's negative 2. And 4 divided by negative 2 is negative 2. So normally at that point, I go ahead and I do 2 things. I first draw the axis of symmetry, dash line at the negative 2, and I go ahead and I copy that x coordinate down for the vertex, because now we know that the vertex starts with negative 2, and the only way to find y is to do a plug and chug. So the plug and chug is back in that original equation. So you would do negative sign, and then in parentheses plug in a negative 2, square it, minus 4 times negative 2. I know that just made that look like a positive sign, but it's not. And then minus 3. What did you guys get for y? A 1. Okay, so if by chance you happen to get some number that does not fit on that graph for the y value, you probably just typed something in wrong, or your x value was wrong. So don't leave a number, like if you get, what was it, negative 15? If you happen to get negative 15, it's because your x value was positive 2 and that was wrong. So if you get an answer like negative 15, don't leave it because you know you've messed up somewhere. Okay, so try to go back and fix it. Negative 2, 1, plot that point. And then what's next? Okay, we can't find the zeros until we do what? Well, technically you could, but I didn't teach that.
The two numbers?
Yeah, two numbers to the left or to the right. So we have to make a little T-chart, right? Okay, so your two options are, we could go with negative 3 and negative 4, or we could do negative 1 and 0.
Negative 1 and 0.
Okay, sounds good to me. So if you do negative 1 and 0, if you plug in a negative 1, you should get 0 on your calculator.
Into this?
Yeah, so you should already, do you already have it typed in once? If you already had it typed in once, you could just go into your memory and change that negative 2 to negative 1.
You said 0?
Yeah, you should get a 0. And then if you plug in 0, that should be able to be done mentally. Because my first two terms would just fall out, right? They disappear.
Do I only plug it into this?
You plug it into the whole equation. So you want to put it where the x is here and here. But you've got, okay, hang on. You've got to make sure that you put the negative sign out front. I think I just erased it. Yeah. But you have to put a negative sign out front. No. You have to have a negative sign, then parentheses, then negative 1.
Why do I have to already have that?
Because this is the same as negative 1 times that. All right. So if you guys plot the negative 1, 0, and 0, negative 3, and then you mirror those 2 points, you'd end up with a point here at negative 3, 0, and at negative 4, negative 3. And you have just created the parabola facing down, which from the beginning you would have known it was facing down because that negative sign, right? Now the zeros you can get right from the graph. The zeros are the x-intercepts. So what are the two places it crossed the x-axis? Negative 1 and negative 3. I don't typically write those as ordered pairs, but you can. I mean, you can write negative 1, comma 0 and negative 3, comma 0. But typically when we solve for zeros, we usually just have x equals a number and x equals another number. So domain is always what?
All real.
All real numbers. Everybody should get that point. And then your range, remember, axis of symmetry is the x-coordinate of your vertex. Range is always going to have the y-coordinate of your vertex. It's always going to say y. Then it's going to be either less than or equal or greater than or equal. How do I know that one's less than? It's facing down. As long as it's facing down, you put the less than or equal. If it had been facing up, you guys would put greater than. Okay? Good?
Yes.
I know it's been a while since we did some of those. That's why I said, like, the beginning of the practice final was actually harder. Because then as you moved along, hopefully it got a little bit easier because they were things that were more recent. All right, number 6. Find all zeros. That means set the whole thing equal to 0 and factor. So what kind of factoring do we have to use here? Yes, grouping.
Do you have your practice sign?
Oh.
It's in the
You can, I mean, if you need to like review it,
Yeah.
kind of go back and forth, you can.
Okay.
Okay? All right. Sorry, I'm trying to multitask here. All right, so for the grouping, the first two have x squared in common. What would be left in parentheses? 4x minus 1. And then your second set of parentheses have a 2 in common. Remember, you have to keep that minus sign. If it had been a plus, you'd keep it plus. And then when you do your division, when you take the second set and you divide by negative 2, you should get 4x minus 1. Again, you should get the exact same thing, which you do. Negative 8x divided by negative 2 is 4x, and 2 divided by negative 2 is negative 1.
So then those suffers will be.
We're going to have x squared minus 2 goes together, right? And 4x minus 1. And now you just have to separate those and set them both equal to 0. I'm going to start with 4x minus 1. I'd add 1, so that would become 4x equals positive 1. And then when I divide by 4, you get a fraction. That's okay. X is 1/4. Now, if you wrote 0.25, it's fine. Now, this other one, if I add 2, I don't get x equals 2, I get x squared. So what do we have to do? Square root. And anytime you take the square root, make sure you put that plus or minus sign out front. And do we know the square root of 2? No. So you just leave it as a radical 2. You know, if you get a number like 2, 3, 5, 7, if you, 6, if you get any of those numbers under there and you don't know the square root, just leave it. Just make sure you guys put the plus or minus symbol in front. Feel pretty confident in page 1? Okay, flip it over. All right, so number 7. On your Unit 4 test, there was one just like this, and the one thing people tend to forget is what happens here on the bottom. Everybody knows up top that they're going to probably do an asterisk, and we're looking for the 2 that make 36 and 13. 4 and 9, good job. All right, now for the bottom, if you don't get rid of that 2, see right now some of you might have done 2 times 8 and put a 16 at the top, and you might have put a 10 at the bottom. The problem is anytime you guys factor, step 1 is always, is there a GCF? Is there something that we can bring out front? Well, all of those are divisible by 2, correct? So really what you should have done first is cut everything in half and leave the 2 out front. What ends up happening is if you do the asterisk with a 16 up top and a 10 at the bottom, your 2 ends up disappearing. And so you don't get a right answer. So if there's ever a GCF, bring it out front. So how about 4 and 5? 4 and 1. So I'd have x plus 4 and x plus 1. Notice how that 2 is still out front. Okay, then your x plus 4's cancel, and that's it. So we have x plus 9 up top and 2 parentheses x plus 1 on the bottom. You're fine. We're flexible and adaptable around here.
Sorry.
That's fine. Okay, so problem number, was everyone good with 7? Okay. Yes, number 8. Number 8 is multiplication. So I use the box method. A lot of you just distribute. Whichever method you prefer, just go with it and do it. Just keep in mind that with I, you guys are going to end up with an I squared term. And remember, I squared is going to drop out, and you're just going to make that whole number the opposite sign. So 7 times 5 is 35. You should have had a 28i somewhere, depending on which method you're using. You'd also have negative 10i. And then this corner is the one you got to be careful on. It's going to start out as negative 8i squared, but that will just become positive 8. Because remember, I squared equals negative 1. So this is the same as negative 8 times negative 1, and that's why it becomes positive. So don't ever leave I squared in your answer. And yeah, the I squared equals negative 1 is on your reference sheet. It's on the front, bottom right, or bottom left-hand corner, I think. And then you just combine terms, right? So 35 plus 8 is 43. And your two I terms will make positive 18i. And then that one's finished. Number 9 is super, super easy and should be really fast. For vertex, one of them becomes the opposite and one of them stays the same. Yep, 3 changes, so the negative 3 becomes positive 3, and the y stays the same. Yep. That, I believe, is also multiple choice on your final. And just keep in mind, they're going to have every possibility. They're going to keep, the negative sign in front of the 3. They're going to change the y instead of the x. So you'll have 4 options. Just make sure you pick the right one. Okay? Change x, keep y the same. Everybody good?
Yep.
Okay, so number 10 is a type of problem that I taught the day I came to Anderson. Woo! It was so much fun. Huh?
I know, but I just remember her shirt.
Oh, my shirt. Okay, yeah. I was figuring out where you guys were going with that. Okay, so for number 10, the denominators have nothing in common. So in order to find a common denominator, we'd have to use both. We'd have to use the 3x plus 1 and the x plus 2. So if you guys take a look at the fraction on the left, you are going to end up multiplying the numerator and the denominator by x plus 2. So you're multiplying it by the one pretty much diagonal from it. Well, I don't like to say cross multiply because that's what you use when there's an equal sign between them. But you are multiplying it by the one diagonal from it. So, I mean, it's kind of the same process, but we can't really use that term because there's no equal sign. All right. What would you guys get if you multiply 2x by x? 2x squared. And then 2x times 2 is 4x. Now my denominator used to be 3x plus 1, but now it's that whole denominator, right? The 3x plus 1 times x plus 2. So, Haley, you never got this lesson. That's why you might be a little confused right now. All right, now my second one, this is the one that takes a little bit of time because it says you have to multiply x minus 3 times 3x plus 1. So I'm going to do another box problem. A lot of you would probably at that point distribute. Again, it just all depends on what you're more comfortable with. So I would take x minus 3 and be multiplying by 3x plus 1. Okay, so take a look at that box. We have a 3x squared minus 9x plus 1x minus 3. So when you go to write this second numerator, just make sure you combine, let's see, negative 9 plus 1 is negative 8x. And finally, the majority of this problem's done. All you guys have to do now is write the two fractions. We're going to combine my numerators, and we're going to leave the denominator the same. So we're just combining. What would combine up top?
3x squared, 2x squared.
Okay, so
Yes.
total of 5x squared. Then your two x terms. You have 4x with a negative 8x.
Negative 4x.
Negative 4x. And then the minus 3 is hanging out by itself. And then you just have to copy down your denominator one more time. Now, technically at that point, even when I was in Anderson, I told you guys you should try to factor the top, try an asterisk, because if by chance one of the set of parentheses was 3x plus 1, we would have to cancel it out. Did anybody actually try it? Okay, well, here's the good news. Is there any way that we would have two numbers that would multiply to make negative 15 that would add to make negative 4?
No.
No. So that top actually doesn't factor anyway. And if it, if the one on your final does and you forget to do it, it's not like you're going to lose all your points. You'll get partial credit. So, all right, how are we doing? Everybody good through 10?
Yes, ma'am.
Okay. All right. Number 11, inverses. Can't write with an eraser. Y equals the 4th root of x plus 2 minus 3. Okay, so all I've done is I changed f of x to y, and then you trade places of x and y. Everyone remember doing that? And then, what do I do? Add 3 to each side. Whew, man, there's just not enough room. See, when I was typing this up, I had it blown up on the screen. So I thought there was way more space until I printed it out. So, okay. So now I have x plus 3 equals the 4th root of y plus 2. How do I get rid of that 4th root? So raise to the 4th power.
Yep.
And the left side is going to stay x plus 3 to the 4th. The right side, the 4th root and 4th power just cancel each other out. So we have the y plus 2. Then you subtract 2 from both sides. And my final answer is x plus 3 to the 4th power minus 2. And your final notation, remember your inverse notation has the negative 1 as the exponent. So the inverse of f of x equals x plus 3 to the 4th minus 2. Done. Good? Oh, I heard a no? Okay. Looks like you guys get to have fun on Wednesday. I want to come to your fun day there. Okay, number 12. Division always gets turned into multiplication, right? We do the keep, change, flip, and we factor everywhere that we can. You guys will factor here, here, and here. But just remember, this side will flip. Greatest common factor for most of them. What are 6 and 54 both divisible by? 6. So that becomes p minus 9. Keep the 6 out front. And then the bottom's divisible by 8, and you get p plus 9. Then that division symbol changes to multiplication. The p plus 9 that was on the bottom now goes up top, and the most work comes from factoring what was on the top. What makes 18 and negative 11?
Negative 9.
So p minus 9 and p plus 2. Yep. And now you just start canceling away. So p minus 9, p plus 9. If you have numbers out front like 6 over 8, that can reduce also.
Would be P minus.
It should be P minus 2.
What did I do? Oh, yeah, thank you. Sorry, both of those were negative. My mistake. Okay. What do 6 and 8 reduce to? 3 and 4, because they can both be divided by 2. So the only thing left up top is a 3, and on the bottom we have a 4 and a p minus 2. All kinds of factoring. Okay, so 13. 13 says, what is the discriminant? So in order to solve any kind of quadratic, everything still needs to be on one side. So before I even get started here, we want to make sure that we take that negative 5 and move it to the left. So what will it be on the left side? It'll be a plus 5, yeah. So this is just going to become 3x squared minus 2x plus 5 equals 0. Okay, so how do we find discriminant? You do the b squared minus 4ac? Yep. So you guys would want to do a plug and chug with that. Which one is b? Negative 2. Remember, all negatives have to go in parentheses when you square them. Minus 4 times a times c. Now, I think I copied this problem when I made the practice final. I think I copied it straight from the unit, whatever test, unit 2 test. I don't know if I had given you that or not. Yeah. Okay, so if you guys do negative 2 squared minus 4 times 3 times 5, what do you get? Because, remember, it was negative under the radical, and to get rid of the negative, we bring out the letter I. Yeah, that's just to make it go from negative 56 to positive 56. Okay, pretty good? All right. Now, I think from 14 on, they're going to be hopefully easier. They're more recent. So hopefully, you know, like as you were working, you were like, oh, finally something I remember how to do without looking back at my notes. So we've done one of these pretty recent. Before I even fill out this chart, you guys could tell me if that's growth or decay. How do you know just by the equation? Yep, it's growth, right? Growth because b is greater than 1. So the b value, which was 2, was greater than 1. Now, we're always supposed to use negative 2 to positive 2. Is that right? 1/2, 1, 2, 4, and 8. Yeah. And then when you guys plot them, I don't know if I'm going to be able to do this because this is going to be So tiny on mine. 0, 2, 1, 4, and 2, 8. Now my other 2 points, negative 1, 1. Okay, well that's good enough. But after you plot those, remember if there's one that just doesn't happen to fit, just don't plot it. But plot whatever fits, and that bottom should always kind of run parallel to the x-axis to start with, and then it just kind of shoots up, okay? Y-intercept, you guys can get from the equation or the graph. Where does it cross? 0, 2. Yep. Okay, good. So that was from Unit 5. Number 15 is multiple choice. So I guess here, remember, vertical is y, and the y always stays the same. Horizontal is x, so this is the one that needs to become the opposite, but the 4 should stay. So which answer did you all choose? A. Yep. The negative 1 becomes positive 1, and it would be with the x, and then the positive 4 stays the same. Okay, good. Number 16 is from Unit 5 also. This is where you guys have to have the same base. It is 1:30 right now, so I am going to try to hurry. 27 is 3 to what power?
3 to the third.
Yep. So as soon as you get that 27 written as 3 to the third, set exponents equal, and just solve for m. Did you guys get 5/3?
Yeah.
Okay. Yeah. So m is 5/3. Okay. 17, 4th root is 625, e to the 8th to the 3rd power. So the 4th root of 625 is 5. And then when you take the 4th root of v to the 8th, remember you just divide your exponents, or your exponent by your root. So it's v squared. And then you have everything to the 3rd power. So what's 5 to the 3rd? 125, and now this is where you multiply your exponent, so that becomes v to the 6th. So always divide the exponent by the root first, and then multiply the power to the power last. Everybody good? Okay. Now these last ones, at least here, 18, 19, I'm going to go ahead and just write those out. If you need any kind of explanation, let me know. But we are just expanding. So exponents come out front. Division becomes subtraction. And then we're going to do the opposite on 19. So we're condensing. Log base 3, and then that would become m to the 4th divided by n to the 8th. And then you're finished. So one expansion, one condense problem. 20, we get to use a proportion. So I compared length and width. So we have a length of 24, not a width, a weight, sorry. A length of 24 with a weight of 30. And then they give us another weight. So the 10 actually has to go on bottom. So always pay attention to what other number they give you. If it had been inches, we'd have to put the 10 on top and the x on the bottom. But then from that point on, it's just cross multiply. So 30x equals to 40, and when you divide by 30, x is 8, and this was, what, inches? Good?
Yep. It's fair.
Okay. 21 doesn't take much time at all. This is just b to the x equals y. So to go to log form, always put the base a little bit beneath it. The y should be even with the word log, and then the exponent is what you always set it equal to. That is also on your reference sheet. So don't forget, as long as you can use that reference sheet, go back and forth between them. (22) I am going to square both sides to get rid of that radical. Most people do okay on the right side. It's the left side that sometimes I worry about, because n plus 2 squared is not n squared plus 4. You will end up with an n squared and you will end up with a plus 4, but there is a middle term that a lot of people tend to forget about. So n times n is n squared, 2 times 2 is 4, but we also have 2n from here and 2n from here. So what's 2n plus 2n?
4n.
All right, so there is a middle term of 4n, and then just move everything to the left-hand side. And then we do our asterisk or factor. What two numbers do you get? Haley, you did this right on your test, but at this point you stopped when you had your two sets of parentheses. Okay, so like go to your two final answers, just write their opposites. So n plus 9, that would be n equals negative 9, yeah. And then the other one's n equal 3. So you can do corrections on that one too. Okay. All right, so there are my two answers, and I did remind you to check for extraneous solutions. Which one of those is false? Yeah, it's the negative 9, because when you put a negative 9 right here, negative 9 plus 2 is negative 7, and you would never have a radical equal to a negative. So the negative 9 is extraneous. The 3 worked out fine. You okay with that? Okay. All right, then we have division. Are most of you using synthetic?
Yep.
Okay, so for this problem here, you guys could do either method. I just always use synthetic. Remember, 3 rows, number of columns is based on 1, 2, 3, 4 terms. So since there were 4 terms, you get 4 columns. And across the top, just the coefficients, right? The number outside is the opposite of that one, because it's when you take n plus 10 and set it equal to 0. So you would want to make sure that you actually put negative 10 out front. First one always drops straight down, and then it's just multiply, add, multiply, add. So negative 50, this becomes a 5. Negative 50, negative 1. 10, negative 7. You were here for that, weren't you? No? Yeah, you were. You keep telling me you weren't, but I swear you were.
Okay,
Yes.
so you take the 5 times negative 10, right?
Mm-hmm.
Next, what do you do?
Okay, so you do negative 10 times 5, which is negative 50, and it goes here.
Okay.
And then you add coming down.
Okay.
So 55 minus 50 is 5.
So then you would take the top, the 55.
No, you go back out here.
Okay.
This one times this one.
Okay.
Yeah, so you're constantly doing add going down, multiplying like diagonally. The number out here times the bottom. You put it in the next column. Then you add going down that column.
Okay.
And then negative 10 times negative 1 is 10. Add.
All right.
Okay? All right, and so your remainder, which was that negative 7, that's the part you have to write as a fraction. So the 5 goes with n squared. Remember, you always have to drop down 1 in your final answer. So if it started out as n to the 3rd, our first term in our answer will be n squared. So 5n squared, this 5 is the 5n, minus 1 is the constant, and then this part is your remainder. You just take your negative 7 and place it over what we divided by. Okay, we're coming near the end. Sorry I went over. 24. These are back to imaginary problems, and this is division. So complex conjugate of 8 plus 6i, what's the only thing I change? The symbol in between them, right? The operation. So instead of 8 plus, it's 8 minus. Basically, they're asking you, what are we going to multiply both the top and bottom by?
8 minus 6.
Yep. And then for B, where it says, why do we use the complex conjugate? Well, the whole point of multiplying by 8 minus 6i is so what disappears? Yeah, so that the I in the denominator goes away. So I don't know how you want to say this, but I'm going to just say get rid of I in denominator. I'm going to just abbreviate for now. Okay. All right, so the top multiplication problem is much easier than the bottom because up top we only have to distribute. What's 2 times 8? Yeah, and then 2 times negative 6i is negative 12i. Okay, now the bottom is going to take a little bit of work because it's this times this. So I made a box, but the good news is if you remember, what 2 are always going to cancel out? The 2, like if you're looking at the box, these 2 will, right? Won't the ones across from each, like diagonal? Yeah, because one of them would be positive 48i, the other one would be negative 48i. So this is 64, and then this would be negative 36i squared, so that just becomes positive 36. What's 64 plus 36? 100. Now that would be your final answer, unless they all reduce, which they do. They all have a common factor of 4. Are you getting antsy? Yeah.
Yes.
Okay, so if you divide everything by 4, it's 4 minus 3i all over 25. Good?
Yeah, but you had it. We had a whole bunch of time that we're trying to make things. I remember being so proud of everybody that they actually stayed on the show.
Okay, 2 more to go, and then I'm going to be done forever with you guys. It's so sad. Okay. Okay, so number 25, this is a problem pretty much straight off of your Unit 5 test. So you drink a beverage that has 80 milligrams of caffeine to start with.
That's a hard one.
Each hour, the caffeine decreases by 15%. So 15% would be 0.15. And if it's decreasing, would we be adding it to 1 or subtracting it from 1?
Subtracting.
Okay, so in parentheses here, I'm just going to have 0.85. It says how long, so we don't know the exponent. How long will it take until you only have 30 milligrams left? So the 30 is what goes out front, and we leave x as our exponent.
You identify maybe an X, like you normally do.
We are going to eventually, but we've got to do one thing first. We've got to get rid of that 80. So if they've multiplied by 80, what do? We're going to divide both sides by 80. Didn't this work out to be 0.375? Okay, so now once you guys get rid of that 80, what you have left in front of you is exponential. It's an exponential form. That's, as soon as you see that, we're going to turn it into log form. So this is where you would figure out, okay, here's the b, there's the x, and here's the y, and you would write it in log form. Because then we can just do change of base and call it a day. Just make sure you set those up right. Your 0.85 is your base, so that goes under, and the 0.375 is your y. So then when you guys do change of base, make sure you put, the base always goes on the bottom. So it'd be the log of 0.375, that one, divided by the log of your base. And what are you guys getting as your answer?
6.04 hours.
Okay, so I'm going to just, if you guys said it was 6.04, I think I left mine with those 2 digits as well, and we're talking about hours. So it would take about 6 hours for it to go down to 30. Last problem, right? Okay, so number 26. Now this one was actually from Unit 2, so this one was kind of old. Oh, and on this practice final, I did not put a probability or the mean, median, range, but we just did those last Thursday. So you will have one probability problem. It's super simple, I promise. And you'll have one problem where you have to do mean, median, range. Okay? On top of these.
Like you do now from Thursday.
Yeah, like the do now from day 28. Yep. All right, so this one talks about a foul ball leaves the end of a baseball bat and travels according to the formula. They give you this function right here. Remember, this is an upside down parabola. And they want to know how long it's going to take for it to reach a height of 96. So I set the function equal to 96, but anytime you see a quadratic, we have to move everything to one side, right? Set it equal to 0. So I'm just going to take this positive 96, I'm going to stick it right there on the end, and it will become negative. And what number can we always factor out of these kinds?
Everything.
Negative what? Negative 16. Factor that thing out of there. You don't want to mess with it anymore. So divide everything by negative 16. And what you see right here in parentheses, that is the only part of this problem that matters. That negative 16 doesn't matter because it doesn't have a letter with it. But when you factor this part, you'd get t what?
Negative 3 and negative 2.
Okay. Now, because you get 2 negatives, won't both of my answers be positive?
Yes.
Okay. If we're talking time, and you guys get 2 different answers that are positive, they are both correct because it would hit a height of 96 going up and coming back down. So what has happened is this happened at 2 seconds, and then 1 second later it hit 96 on its way back down. Okay, so if you get 2 positives, leave them both. If one of them is negative, cross it out and just keep your positive. And that's the end of the review.